help to bring the latest technologies, programs, and tools to the comfort of your office and provide a format to ask questions that will help you discover the right solutions for your operations. Partners in Project Green offers many resources, and I encourage you to visit our website at partnersinprojectgreen.com. And that's about it. So this afternoon, we are exploring a very interesting topic, at least for me, is LED lighting. We're very fortunate to have Sheldon Rodriguez from EnerSource and Ed Evans from Osborne, Pennsylvania, joining us this afternoon. First up, we have Sheldon Rodriguez, who's the CDM Conservation Analyst with EnerSource. Sheldon has 7 years experience in energy management with a bachelor's degree in business financial analysis. Now, Sheldon, I'm going to unmute you right now, and you can take it on.
Thank you, Alex. Good afternoon, everyone, and thank you for joining us today. As mentioned, my name is Sheldon Rodriguez, and I've been working with the retrofit program since its inception. Prior to that, I was working on its predecessor, the ERIP program, and some of the residential conservation programs as well. So I'm just going to briefly go over the residential programs and then hand it off back to Alex to introduce the next speaker. Our first, can we go to the first slide, Alex? The retrofit program exists to provide financial incentives to encourage our commercial, institutional, and industrial customers to upgrade their existing equipment to an energy-efficient option. Alternatively, in the case of a complete failure or end of useful life situation, the retrofit program serves to encourage customers to choose energy-efficient replacements over their standard options. There are 3 tracks to choose from: prescriptive, engineered, and custom. Alex, can we move forward to the track slide?
There's a bit of a delay, Sheldon, and I do have it over. It'll come up in momentarily.
Okay. Should I continue or?
Yeah, you can continue.
Okay.
Yeah.
So the three tracks you can choose from: prescriptive, engineered, and custom. The prescriptive track covers items such as VFD, unitary ACs, and lighting, among other things. Prescriptive is the simplest of the 3 streams, and the incentive is calculated using assumptions or generalizations on what the existing base case is you have in your facility. Incentives are based on a per unit or dollar per unit amount and are capped at 100% of the material cost. So that is the cost of the materials purchased and installed. So no labor or any other costs can be included in that. The second approach, which is the engineered approach, is for projects that do not qualify under the prescriptive approach or for customers who do not choose to accept the assumptions under the prescriptive path. Engineered lighting project incentives are calculated at the greater of $400 a kilowatt of demand savings or 5 cents a kilowatt hour for the first year's energy savings. And these incentives are capped at 50% of eligible project costs. In an engineered project, the eligible project costs are material, labor, cost of disposal, as well as any kind of licensing and duties. Non-lighting projects, non-lighting engineered projects are similar operation, except they're capped at $800 per kilowatt or 10 cents per kilowatt hour. And these are capped at 50% of eligible costs as well. Just a little side note on the above. Any LED projects claimed under prescriptive or engineered must have either Energy Star qualification or a DLC rating. This is one of the rules that has been handed to us from the OPA, and all of the LDCs enforce that pretty much the same. Okay. Now, the final path, custom projects, these are projects that don't fall under the engineered or prescriptive approaches. In terms of lighting, this would include fixtures, lamps, that would be considered specialty lighting, and their category would not necessarily be covered on either the Energy Star or DLC list. In terms of other projects, non-lighting, this would include things like compressors or time of use type systems or daylight monitoring systems. Custom lighting projects incentives are calculated at the greater of $400 per kilowatt of demand savings or 5 cents per kilowatt hour of the first year's energy savings, same as the engineered project. and these are also capped at 50% of eligible project costs. Non-lighting projects, which would be your motors and so on, these are capped at $800 per kilowatt or 10 cents per kilowatt hour, and are also capped at 50% of eligible costs. Another little side note, the demand or kilowatt savings as defined in the program is defined as 11 a.m. to 5 p.m. from June 1st to September 30th. So if your savings occurs during that time, you get the increased incentive of either $400 for a lighting project or $800 per kilowatt for a non-lighting project. So this is just a brief overview of the program. I will be available at the end of this presentation to answer any further questions you may have. And I will now hand it back to Alexandra to introduce the next speaker. Thank you very much.
Thank you so much, Sheldon. And as you noted, you will be available for questions at the very end. Up next, we have Ed Evans, who is the National Account Manager in LED with Osram, Sylvania. Ed is a recognized leader in lighting industry in regards to energy efficient, sustainable lighting solutions with a focus on new LED products and technologies. Ed is responsible for supporting Canada's institutional, commercial, and retail property managers transition to LED and ensure that best possible payback, return of investment, incentives, and sustainability benefits are achieved. Ed has managed hundreds of energy-efficient lighting projects, which have resulted in savings of many megawatts of electricity and millions of dollars in cost savings. At home, Ed lives in a LEED Platinum home with part of one of Canada's first LEED Platinum neighborhoods he helped to champion as a community volunteer. And Ed is with me today, and I'm just going to hand him over the speaking arrangement.
Okay, thanks very much, Alex, and good afternoon, everyone. I'd like to begin our presentation with two quick thank yous. First of all, thanks very much to Alex and her team at Partners in Project Green for organizing this webinar, and of course to the partner utilities, EnerSource, Toronto Hydro, and Brampton Hydro 1, and your conservation team's great support for our commercial customers and the significant energy conservation incentives you provide, particularly for important new energy-efficient products and technologies such as LED lighting. We're very excited to be speaking this afternoon to one of the most sustainable energy conservation measures possible today that provides surprisingly good paybacks with the ERE incentives Sheldon just covered, LED lighting. Also, very important thank you to all of you for investing your time here with us this afternoon. We know how busy you are as leaders of your respective organizations and market sectors, and our commitment in this LED presentation is to provide you with very valuable information regarding this very exciting new LED lighting product range and energy conservation opportunity, including case studies of some of the most energy efficient and sustainable lighting systems in Canada today. We'll review the key information for an LED action plan. Specifically, how to achieve the greatest electricity dollar cost savings, maintenance savings, best possible light quality and performance, and the business case for the best possible payback, ROI, and maximum incentives for the LED project in your facility. So we'll look at specific, relevant, important LED case studies, including the McMichael Canadian Art Gallery, University of Toronto, Sears Canada, and other projects to examine LED technology benefits and risks, the current LED market, the costs, paybacks, and incentives for the new LED products with a focus on the new LED lamps utilized in the case studies. And we'll begin with just a very quick 1-minute introduction as to who we are at Osram, Sylvania. Osram, Sylvania is one of the 2 largest lighting manufacturers globally, and we're the NAFTA and Canadian leader in the commercial sector. In regards to our market position for LED, we're one of the 2 largest lighting manufacturers globally of LED, and we've been working with LED for over 30 years. In Canada, Osram Sylvania is one of the largest drivers of electricity conservation projects. Several quick points regarding our market position in the global LED market, and this also gives you an overview. I'm going to lead into the current LED market globally and in Canada. We are the industry leader for R&D for LED. We hold over 4,000 patents in LED technology, and our 30 years of work of LED have resulted in numerous industry-leading achievements. a market share of 70% of all LED installed in automobiles manufactured in North America. The new Mustang is the first production car where all onboard lighting is LED, and it's all Osram. The acclaimed Audi headlamp system, the Cadillac Escalade headlamp system are all Osram LED components. And this also gives you a sense of how far the LED market has progressed over the past 10 years. 10 years ago, the first great growth with LED lighting was in the automotive sector, and it was just dashboards and taillights, situations, applications where you wanted to light something up. You could see it from a distance with the lowest possible wattage. Now, as you can see from this evolution in the market, LED is powerful enough to power the most powerful headlights on high-performance automobiles. In our lab, we often refer to some of the new LED products actually as light cannons. So now with these breakthroughs, the growth of LED technology in the automotive market and other sectors, and R&D poured into this technology, over the past several years, our industry has achieved significant breakthroughs in these new LED retrofit lamps with quality to replace incandescent and halogen lighting, and many other new LED retrofit products and fixtures for both interior and exterior lighting applications for commercial buildings. And here are the major trends in the global lighting market 2010 through 2020. And this data is from a 2011 McKinsey report based on input from leading global lighting engineers and manufacturers, and it helps to explain why new LED products can achieve some of the greatest energy cost savings, best payback ROI of any energy conservation product in the market today. Please note the LED or blue area at the top of the chart. In 2013, LED now comprises still less than 10% of what we refer to as the general lighting market. That's the lighting market for commercial buildings. However, within 5 years, over 50% of all lighting globally is projected to be installed LED. Within 10 years, over 70% of all installed lighting in commercial buildings globally, and certainly we expect Canada to be a leader, will be LED. And this is solely driven by the business case, by the quest to lower the operation costs in commercial buildings. It's all driven by energy savings and the business case of the payback ROI. And the reason is that this chart shows LED market growth, but it also reflects the ever-increasing efficiency of LED and the significant range of different types of LED opportunities for energy cost savings that have come into the market. It also reflects ever-decreasing LED costs for better ROI. It also reflects in markets such as Ontario very significant incentives, utility incentives for LED, and as Sheldon remarked, with most LED projects, we'll show in the case studies in the slides to follow, you can achieve up to 50% of capital costs for LED projects with the ERE incentives in Ontario. So it's all about the relative efficiencies, or the lumens per watt, the LPW, which is the miles per gallon of our industry. The chart shows rapid LED market growth now as LED lamp sales have exploded due to the relative efficiency of approximately 70 LPW for LED lamps versus only 5 to 40 LPW for incandescent and halogen lighting. And now LED fixture efficiency is greater than 100 LPW, surpassing high-pressure sodium and metal halide lighting technologies, which are the traditional exterior lighting technologies. In the lab, we've surpassed 140 LPW, which will drive the LED market transition to overtake even T8 fluorescent and T5 fluorescent, which are still the big hitter kings of energy efficiency, and they still remain unsurpassed T8 and T8 in the 100 to 120 LPW range. However, LED efficiency is projected to reach 200 LPW over the next 5 years, and it's over that 5 to 10 year period that this much higher energy efficiency of LED will drive the business case for it to replace most every other lighting technology over this time. And here are the key reasons why LED is a big game changer for energy efficiency and sustainability for lighting. Regarding sustainability, LEDs are free of hazardous material. In particular, they contain no mercury. The 10 to 20 times longer life LED lamps versus incandescent and halogen means much less lighting going into landfill. And the fact that LED lamps use 75% less energy than incandescent and halogen, with energy savings for other LED applications ranging from 20% to 70%, you've got very significant energy efficiency and energy savings across the board with LED technologies. As LEDs emit less heat, air conditioning loads are lessened, and as LED lamps and other LED retrofit products utilize existing light fixtures, again, this reduces the amount of lighting product going into landfill. The reason why the LED market has begun to explode over the past 12 to 18 months or so is due to the rapid market uptake of these LED lamps, which are absolute plug-and-play, simple retrofit products. And these products provide the greatest percentage energy savings of all the LED products at 75% plus. They also, far and away, provide the best payback and ROI. By maximizing E-RE utility incentives, a payback of less than 1 year is typical on commercial building hours of operating in the 3,500 to 4,000 hours typical office hour range, as we'll see in the case study to follow over the next several slides. And these high-quality LED lamps have achieved a high quality of light and light levels when compared to incandescent and halogen. All of them have a rated life 10 to 20 times longer than the typical inefficient incandescent and halogen lamps that they're replacing. So therefore, there's now a highly viable and compelling business case to replace all remaining incandescent and halogen lighting, particularly in all commercial buildings, as this is proven to be one of the best possible energy-saving ROI and green sustainability measures you can undertake today. The McMichael Art Gallery LED project is a particularly compelling and useful LED case study. Most importantly, because there's no facility where quality of light is more important than a leading public art gallery. And the McMichael project utilizes various LED lamps and LED exterior fixtures. The primary application at the McMichael is the use of 15-watt LED par 30 lamps to replace both existing 50-watt and 75-watt incandescent and halogen par lamps. This close to 600 LED lamp portion of the McMichael project resulted in significant energy savings of over 30 kilowatt load electricity savings. The project payback regarding electricity savings, when you include the E-RE incentives with a very conservative lamp replacement savings, a payback of less than 1.5 years was achieved, and payback was only that high because the hours of operation were only about 2,700 hours a year, much less than a typical commercial office building. Again, the McMichael is a wonderful case study because you not only have LED products, lamps, and other types of LED lighting throughout the interior of the building. The McMichael has also retrofitted most of the exterior pathway lighting at their facility to LED as well. So if you're considering a major LED project, you want to prove to yourself and your team that LED lighting is indeed the quality that you require, the McMichael is a wonderful public institution where you can walk through an actual case study at that site. And here's a snapshot of the typical payback for this 15-watt LED par 30 when replacing a 75-watt par incandescent. And this is the first step in the LED action plan that a good lighting professional can facilitate for you at your facilities. Generally, if it's a manufacturer, electrical distributor, it would be provided, these assessments, certainly through Partners in Project Green and the team of reputable professionals they're working with. These assessments are generally provided at no cost. At least that's the case on the part of our team and the team that we work with. So based on a site visit and assessment, there would be a review of your existing lighting, and then recommendations would follow regarding the best new LED specification. You would be provided with capital cost, incentive calculations, payback, and energy savings by dollar, energy savings by kilowatt and kilowatt hour. And as you can see, for these LED lamp retrofits, the results are very dramatic. For a typical commercial building, operating hours of 3,500 hours per year, based on receiving the ERIE engineered incentives, the payback is only 9 months, and that's for electricity savings only inclusive of the ERIE incentives. With incentives of up to 50% project costs, in this case, in the range of $17.50 per lamp incentive, and an annual cost savings of $23 in electricity savings annually per lamp, this excellent payback is achieved. When lamp replacement and maintenance savings are factored in, the payback is actually in the 7-month range. A similar payback is achieved with an LED MR16 retrofit. When we replace an existing 50-watt MR16 halogen lamp with our new 7-watt LED MR16, again for the typical 3,500 hours per year with the ERIE incentive, the payback is well under 10 months. And again, to the electricity savings only, when you factor in lamp replacement and maintenance savings, once again the payback is actually 7 months. For many facilities that operate their MR16 lamps, their existing lighting 24/7, as often occurs in public lobbies, reception areas, public corridors, etc., the payback actually drops to the 3-month range. So clearly, this makes the business case with a payback in the range of 9 months down to 3 months, depending on operating hours, and making sure that maximum incentives, maximum ERIE incentives are achieved through EnerSource and Toronto Hydro and Hydro One Brampton. With a product lasting 10 to 20 times longer life, there's a very compelling business case to identify and replace any remaining incandescent and halogen lighting in your facilities. Many companies feel that they've already addressed this with compact fluorescent, but many locations throughout a commercial building, lobbies, corridors, particularly meeting rooms, boardrooms, where dimming is still required, there hasn't been the opportunity to convert to compact fluorescent. So you may be surprised if an assessment is done of your facility that there may be a significant amount of sockets left where you can still achieve these very significant energy savings and that outstanding payback. Another case study we're very happy to share with you is a project that we completed now well over a year ago. Sears Canada, we replaced over 116,000 LED par 38 lamps with our new 15-watt lamps. So it actually went from, originally it was 90-watt par 38s. We took it down to a very, very efficient 60-watt par IR halogen lamp. Then we went from 61 halogen down to 15 watts. The result was one of the most significant green sustainable lighting projects in Canadian history. It's a great case study because Sears did 3 years of research testing and comparing over 20 different LED lamp products. The result was 6 megawatts of electricity savings, cost savings for Sears in the range of $2 million annually. And due to the support of leading utilities such as EnerSource, Toronto Hydro, and Hydro One, and other leading utilities across Canada, we received a project incentive of 50% of capital costs, which ended up driving a 1-year payback for this project. And again, with the theme of sustainability, the sustainability benefits were off the charts. This project was the equivalent to taking 15,000 cars off Canadian roads in regards to greenhouse gas benefits. And very important to note that whether your project is 10 LED lamps or 100 LED lamps, these same relative payback, energy savings, and sustainability benefits that Sears achieved can also be achieved for your LED lamp project. Equally important, the information we're providing regarding the great benefit of high-quality LED products is an awareness that there are risks in the LED market. LED is still a relatively new technology, although many of the different LED technologies are very viable and proven. But very important for you to be aware, to do your due diligence, to follow some of these buyer beware steps that many of you, I understand, are diligent, keen energy conservation practitioners, and that you are aware of the general benefits of LED, that they're very inefficient compared to some of the traditional lighting technologies. They have a much longer life for various reasons that we've addressed. They certainly are the most environmentally sustainable lighting product available in the market. And it's now also the case that these new LED products, the higher quality ones, provide a true replacement quality of light and light level. There's numerous other benefits. They're shock resistant. They perform very well in the cold Canadian climate. However, the one great issue with LED is that, as with all electronic devices, heat degrades the LED electronic components. The result is in poorly designed LED lamps that don't have good thermal management design, all of these problems will occur. Lumen depreciation and color shift. We've had a lot of feedback from various major utilities where they've seen this at various customer sites. They've tried to do the right thing, but they jumped the gun, went with a non-E-Star product, went with a lesser quality product. There's a lot of reports where projects installed within 12 to 18 months of initial installation, very significant lumen depreciation occurring, light levels falling 50% or more over the first 12 to 18 months. A lot of examples of color shift where the LED light actually shifts to sort of a greenish tone or other tones. And that obviously, particularly in regards to this lumen depreciation, this light loss, if a product has a rated life of over 50,000 hours, this type of light level loss should not be occurring for well over 5 years. That with a good LED product, should we, okay. Just one moment, just have to take a pause here and just do a bit of a chart, just one moment. Okay, we're back again. So with the LED lamp product, unfortunately we can't show you one right at the moment, but if you held one in your hand, what you would find is they sort of have these fins on them. And basically, the reason for that is that the LED lamp and other LED products, the heat sink is absolutely critical. And an LED lamp is actually designed as a heat sink itself. The reason for that is to move the heat away from the back of the lamp. It's important to understand that LED technology basically turns our understanding of how lighting performs upside down. These new LED products are basically electronic appliances now. There's very, very little heat that now comes out of the front of one of these LED lamps, that there is some slightly higher light levels that occur in the neck of the lamp. And the reason for that is that when the current enters in through the socket and through the neck of the lamp, as with a traditional light bulb, and passes through the power supply in an LED lamp is in the neck of the lamp. So when the current passes through that power supply, resistance occurs. Whenever there's resistance in an electronic appliance, heat is generated. And that if that heat is allowed to build around the neck of the lamp, all of these issues can occur. And so there does exist a potentially serious consumer problem in the Canadian market in that these no-name LED lamps have experienced these type of failures, and these products still are on shelves. It's critically important to make sure you do get an Energy Star rated product, particularly in Ontario, or you can get the incentives, of course. And it's very, very important. The Energy Star approval means that you're going to have a good chance to achieve L70 with your lighting product. And what that means is the lighting product must maintain at least 70% of its original lumen levels over its rated life. If it doesn't maintain 70% of light level over that 5-year warranty, it's considered to have failed. And this is a very challenging problem with LED because all LED lighting, good or bad quality, will last over 50,000 hours. It'll still be illuminated even in 100,000 hours. But if the lamp is only providing 50% or less of its original light level, it's considered to have failed as it's not producing a useful level of light. So again, just brief point on warranties. With the newer, high-quality, brand-name, new generation LED products, these issues of thermal management design and lumen depreciation have been overcome, but it's always critical to make sure you're carefully reviewing the warranty. You want to make sure you get a warranty that refers to L70 maintained light levels. You're making a solid investment in the LED product with a great ROI. You want to make sure you get that 5-year life. The good news regarding these quality and performance issues is that Energy Star has released stringent new criteria to protect the consumer regarding these issues. And take a look at the vertical column, third from the left, titled Lifetime L70 Test. What that means is that all new LED lamp products have been reviewed, or that a new product coming into the market must be submitted to an independent lab for this L70 E-Star test. If it passed the test, it means you're good to go, that the light levels will be maintained for that 70% of rated life. Bottom line, maybe the most important question to ask an LED supplier is, have their LED lamps passed Energy Star testing and have their LED fixtures passed DLC, Design Lights Consortium testing. Time doesn't permit a really detailed explanation of LED technologies, but you can see, for example, we can provide lots of information from our utility partners in Project Green and supplier teams. The lower chart here, for example, provides that technical explanation of LED life, where if thermal design is good, light levels will be maintained, but you can see that red line, if it's burning too hot, lumen depreciation, light levels fall very rapidly. So now in just, I think, the 10, 12 minutes I have remaining here, just very quickly, going to go beyond the LED lamps, take a look at some of the new LED fixture products, both retrofit and new fixtures for a wide range of interior and exterior lighting applications. For new LED fixtures and retrofit products, there are very significant opportunities for energy savings, but the paybacks are just not as low. The payback and ROI is just not as good with the LED lamps, yet that will improve as efficiencies increase and prices come down. But here it's all about the application. With less efficient, shorter life, existing 2-foot linear or some pin-based compact fluorescent, they can be good targets to be replaced by energy efficient LED retrofits based on hours of operation. There may be a business case. However, in areas where you already have high efficiency 4-foot T8 fixtures, it may not make a good payback business case. So therefore, the transitioning of interior fixtures to LED is a very interesting and challenging decision process all major facilities face, and an expert lighting analysis is very helpful in that regard. As shown in the upper right-hand corner of this slide, besides the new LED lamps, one of the very best energy-saving measures you can undertake regarding best payback, ROI, and EOE incentives is a relamp to a high-performance new T8 fluorescent product. These products contain very low doses of recycled mercury, so it's still a very green, sustainable measure, and we'll take a look at that along with these new LED products. This is a really important example. I'm sure that many of you, as large organizations that are trying to do the right thing in regards to sustainability and energy conservation, you've taken a look at this product, and this is the T8 LED retrofit kit. It's a very good example of this challenging dilemma where you really need an expert analysis when you're comparing T8 LED lamps to T8 fluorescent lamps. LED T8 lamps may provide some energy savings. However, depending on the application, these savings can be very marginal, and they may not provide a particularly good ROI business case, particularly when you're comparing current T8 LED lamps to new high efficiency, some of the very new long life T8 fluorescent lamps in the market. Here's an example of one product that's now up to 80,000 hours. In your facilities, most of them will be illuminated by 4-foot T8 fixtures with 32-watt T8 lamps, and there are now high-performance, low-wattage 28-watt and 25-watt T8 long-life lamps. A T8 fluorescent relamp can provide one of the best paybacks of any conservation measure, and certainly a far better ROI payback than a T8 LED retrofit, particularly because the T8 LED products tend to be about 10 times the price. And again, these T8 fluorescent lamps, very green, less than 3.5 milligrams of only recycled mercury in them, so a very green energy conservation measure. This is the direction the LED market will be taking to replace fluorescent lighting. Not the T8 LED tube type product, but these new specially designed LED replacement fixtures and retrofit kits that are powered by what we refer to as distributed arrays of LED. Best applications are opportunities like open offices, certainly educational facilities, healthcare facilities with a lot of existing T8 fixtures. And again, it's all relative. For example, 2 by 2 foot existing T8 fluorescent fixtures tend to be much less efficient than 4-foot T8 fixtures. So if you do happen to have older 2 by 2 T8 fixtures, you may have a very good opportunity for an LED retrofit. However, if they're existing 4-foot fixtures, the payback may be not as good. That being said, if you want to explore it, that there are new LED high-efficiency fixtures that are available in all the same shapes and sizes as the T8 fluorescent footprint. But once again, just make sure you're doing a very, very careful unbiased analysis of the payback and the energy savings. That all being said, it's now possible to fully illuminate an entire building with LED. And with new build or renovations, there's a very good business case, very good ROI for LED versus fluorescent. We've recently completed design and supply of several of the first commercial buildings in North America that are fully illuminated by LED. And to our knowledge, they're some of the most energy efficient light systems in North America, as they consume less than 0.4 watts per square foot. And to give you some perspective on that measurement, a good efficient T8 fluorescent commercial building system usually consumes anywhere in the range of 0.8 watts per square foot up to 1.2 or more watts per square foot. New building codes across Canada, they're now calling for this lighting density measure to be 1 watt per square foot. I understand the new code now, we're now down at 0.8 watts per square foot. And you have to have a good, efficient T8 fluorescent system to achieve that. Again, for example, one of the most efficient T8 lighting systems in Canada is a LEED Platinum Toronto office tower, where the ownership challenged the lighting team to achieve 0.6 watts per square foot, and that was achieved by utilizing the most high efficiency, low wattage T8 lamps and lighting controls. But to our knowledge, 0.6 watts per square foot, that's pretty much it for the greatest possible efficiency of a T8 fluorescent system. This leading-edge all-LED installation utilizes optimized lighting design, state-of-the-art lighting controls, and when that's done, you can achieve this breakthrough lighting power density of under 0.4 watts per square foot. Something that this clearly demonstrates is that over the next 5 to 10 years, without a doubt, in your building and across the market, there is the potential to decrease the lighting load for electricity in your building with LED, even if you have a relatively efficient T8 existing system, up to 50% as the products become available. So again, I want to be careful in what I'm stating here. We certainly don't want to encourage you to go out and explore and push to retrofit your entire building to LED. It's very much based on a specific case-by-case evaluation of your existing lights to the new system. And just very quickly, I want to take 30 seconds to touch on controls. We could do a 30-minute workshop on this, but in addition to LED, the other critically important new lighting technology breakthrough are these intelligent software-driven lighting control systems. These new generation lighting controls offer occupancy controls, smart time scheduling, daylight harvesting, variable load shedding, all these wonderful things. And again, just want to make the point that LED is a perfect marriage with these new lighting controls, and you definitely want to explore them together. I'm going to wrap up now with a very quick 2-3 minute review of some opportunities for LED applications for exterior lighting. And here we do suggest there's a bright green light to take a look at LED exterior lighting applications for parking, pathways, and wall packs, again because of the relative efficiencies. Here's a case study photo of the LED exterior lighting we provided for University of Toronto. This is King's College Circle. Existing back 2 years ago were a quantity of 100 times 150 watt high pressure sodium post-top fixtures, which were retrofitted to a 40 watt LED. Payback on the project was in the 3 or 4 range with ERIE incentives. One of the most significant opportunities for exterior LED lighting is parking garages. It's now viable to illuminate parking garages with LED, and this will be one of the most significant areas of LED market growth in the coming months and years. There are some very good opportunities for ROI here. However, it's all about the right application, analysis of energy savings, hours of operation, performance, life cycle cost benefits. It makes great sense regarding energy cost savings, payback ROI, maintenance savings. If you have existing HID, if you have that metal halide or high pressure sodium in your parking garage, as maybe 20, 30, 40% of parking garages do, you can get a very good payback. Again, however, if your existing lighting is T8 fluorescent, there'll only be marginal energy savings and little ROI and not the greatest business case for LED. So it's always critical to carefully assess your existing lighting, have a good lighting professional come in, put together an energy savings spreadsheet such as the one we're showing here on the screen to make sure you're getting the proper expert analysis to determine exactly what energy savings, payback, ROI, and always that calculation is being made to take advantage of the terrific ERIE incentives to make sure they're being maximized. As you can see here with this project, that we're about to show a case study slide on, the photographs, you can achieve a 50 to 70% energy savings in your facility's parking garage if the existing lighting is high-pressure sodium or metal halide, and with maximized ERE incentives, a payback in the 3 to 4 range can be achieved. And here's a quick snapshot of one of the case studies we've done with LED Parking Garage. This is the Sheridan Parkway Hotel in Richmond Hill. The numbers on the previous slide were based on this payback analysis. So there was a savings of 60% energy savings, payback in the 4-year range with ERE engineered incentives. Again, because the parking garage operates 24/7, a 30 kilowatt load reduction meant over 265,000 kilowatt hours of savings. And again, something very important to note, very significant increase in light quality. So one final application to take a look at, last but not least, LED signage. This is another highly viable LED retrofit opportunity. This LED market transition is well underway. Again, a lot of signs, particularly what we refer to as channel letter signs, not the box square signs, but if you have kind of swooping signs like Yorkdale or Chapters, those type of signs, that means they'll have neon inside, or a lot of signs do have T12 fluorescent inside. If those are your existing signage technologies, you can achieve 50 to 70% energy savings, paybacks under 3 years. Once again, if your sign is illuminated by T8 fluorescent, the payback won't be as good, and it's a measure you may not want to focus on. So to conclude, with new high-quality LED products, there's lots of good news for very important energy conservation opportunities. Paybacks of less than 10 months are typical when replacing existing incandescent and halogen lighting with LED lamps. As a result of electricity and dollar cost savings in the 75% range, 10 to 20 times longer lamp life, achieving very significant lamp replacement and maintenance savings. And thanks to our utility sponsors' outstanding incentives, with all of those LED lamp projects, as long as they're typical commercial office hours, you will achieve the full 50% maximum incentive on your LED lamp project costs. As well, there's those significant energy savings opportunities in regards to LED fixtures, particularly with exterior lighting and some of the other ones we've touched upon with the new LED fixtures and new LED retrofit products. As well, you certainly want to take a look at the low wattage, high performance T8 fluorescent relamp opportunity. Want to make sure I stress the fact that be sure you carefully review the LED warranty to make sure you're getting L70, to make sure the customer, the company that's supplying you, has a good warranty infrastructure in Canada to make sure your LED warranty and your LED investment is properly protected. So certainly want to make the request, the action request here at the end of the presentation. Key LED action plan step 1, have your site assessed for LED energy cost savings opportunities. We and other good partners in Project Green suppliers would be more than happy to provide your organization with a site visit, no cost, no obligation, to assist you in assessing your site for best energy conservation opportunities, focused on LED, site demonstrations, assistance with all calculations, costs, benefits, paybacks, and incentives. So that concludes my presentation. Thanks very much for your time and attention, and we'd be happy now to take your questions.
Great, thank you so much, Peter. That was a great, Peter, I called you Peter, Ed, for the great overview. We do have quite a few questions, and we actually do have some time for others that might come in. The first one, I'm actually going to unmute Sheldon right now because this one is directed to him. If you replace a pump, is that part of the custom project incentive program, Sheldon?
Yeah, pumps can be applied under custom project incentive, and it all depends on when they're actually achieving the savings. But if you have something like a bypass pump or a booster pump, it would qualify for incentives under the custom non-lighting approach. What we would recommend is if you think it's gonna, there's a potential for savings, talk to someone at the utility before you dismiss a project, and we'll review it for you and go over it and advise you on how to proceed. So in this particular case, yes.
Okay, great. Thank you. Now this one is to Ed. What's the best way to compare light outputs of new LEDs with conventional incandescent and halogen bulbs?
Okay, that's a great question, and two-part answer with one qualifier. First point I would make on that is that all the new LED lamps have been designed so that they replace an equivalent halogen or incandescent lamp. So basically we have charts. All leading manufacturers have charts that, for example, if you've got an existing 50-watt MR16 halogen, it shows on the chart the equivalent replacement is a 7-watt LED MR16, or very slightly depending on manufacturer. Then to answer your question specifically, there are two ways to determine, to make sure you're satisfied that you're getting the proper equivalent lumen levels. Number one is that any good manufacturer will have a very, very detailed spec sheet that shows you exactly what the lumen level of the new LED product is, and the center beam candle power, as well as the optical degree range of the beam, and that you can also be provided the same information for the existing product that you're replacing. So you can tell if you've got an existing incandescent that provides 500 lumens, you want to make sure you're getting a 500 lumen LED product. And then finally, the very, very best way is if you're working with a good manufacturer and it's a good size project, ask for some samples or buy some samples, make an arrangement. We don't like to proceed with any LED project unless the customer has installed several samples. So that's really critical. Get your potential supplier to provide you with a couple of samples, pop them in, and take a look at the spec sheet, do your homework, but see for your own eye that you're getting those true equivalencies.
Great, thank you. So this next question is about, I guess, the units and how they do compare between different manufacturers. In one case it's lumens and the other one is equivalent to. Could you say anything to that, Ed?
Yeah, this is another good question. Little bit of a tricky answer, but it's all about the lumens. That any good brand name manufacturer will clearly state on their packaging and will be able to provide you with a specification sheet that will tell you exactly what the lumens are. Sometimes the equivalent to is put on the package simply to try to help the consumer understand what is the direct equivalency. It's also something to be careful of. Don't simply trust ever the equivalent to label. Make sure, you know, that those of you on the line here, you're mostly commercial customers representing good-sized projects, that you make sure you challenge any LED supplier to provide you with a detailed specification sheet that clearly shows you the lumens. It should be marked on the box, but it's all about the lumens. That's the standard in our industry, and you want to be a little cautious about this equivalent to label.
Great, thank you so much. And then this one is about a question on any possible retina damage, referring to a specific report called the ANSYS report. Do you have any information on that, Ed?
Okay, I have to be a little bit careful here. I'm always reminded by my engineering colleagues and my technical colleagues that I'm not an engineer, and be careful to answer these questions, but I'm happy to take them on. And actually, what I should really do is we can be happy to provide you with reports that have been provided that show that there's certainly no adverse health effects to LED. That on the whole, it tends to be a less invasive type of light source, and that, of course, any light source, the sun, various other types of lighting products, if they're not used properly and if you have the improper exposure to them, any of them could cause damage to the eye, that they all need to be used properly. But certainly there is science, plenty of studies done now that show LED pretty much all around is one of the more healthful light sources that have ever come onto the market. So be happy for you to, I've got my email in the presentation, you'd be more than welcome to follow up. But certainly from all the research that we've done, that we've participated in, no cause for concern about health issues surrounding LED lighting.
Great, thank you. So we have actually two questions about the next kind of topic. If LEDs are expected to get better in the next few years, what would be the payback to change them right now and versus in a few years when they get better?
That's a great question. That's one of my favorite questions. And we've helped Sears and many other companies do this analysis. And bottom line, what I would say to that is that even though LED prices will come down a little bit every year, even though efficiencies will build, you will never, ever achieve a better payback with LED, in my opinion, and I think in the opinion of a lot of lighting professionals, because you're in Ontario and because of the EV incentives. That particularly with the LED lamps, absolutely in particular with the LED lamps, I can't imagine you getting a better incentive anywhere. Incentives have peaked. If you can get 50% of project costs and you can get a 7 to 9 month payback, again, we've done studies that LED lighting prices probably won't fall much more than 15% a year. Efficiencies probably won't increase much more than 10 to 15% a year. So if you're looking at a 7 to 9 month payback and you wait a year, well, actually, it's uncertain as to what the incentives will be, certainly after 2015. So again, this is something we would love to help you analyze for your particular facility, but certainly in regards to the lamps, the payback has peaked because the incentives have peaked. If you're looking at a 7 to 9 month payback, I can't imagine how does it make any sense to wait 7 to 9 months to analyze if the project will pay for itself in 7 to 9 months?
Great, thank you so much. How about do we have any standards for LED T8 tubes?
That's another great question, and as I kind of alluded to in my presentation, there aren't a lot of clear standards. LED T8 tubes are quite a new product. We, for example, have a wonderful quality LED T8 tube product, and I am very careful to recommend them. That I feel in most cases that LED T8 fluorescent at a fraction of the price and actually at the same or greater efficiencies are still the best way to go. And I believe that the new the new LED retrofit and new fixture products actually will surpass the LED T8 tube products over the next year or two. So no, the answer to the question unfortunately is no. There's no great standards right now. The wattages, the lumens per watt, there's a range. And that again, please be very careful to make sure you're doing a good analysis to make sure you've got an accurate payback number, because with LED T8 tubes, depending on what you have existing, the savings can be very marginal and that there may be a better option. So definitely work with a company such as ours or another great PPG supplier to get a good professional analysis to help you with your decision-making process.
That's great. And then we have we have a few more questions actually left. This one is interesting. So how are bulbs responsibly disposed of or recycled?
That's another great question, and I wish I had a great answer for it. I do have this answer that it's interesting. I've asked this question. I'm a really green person, and I've asked this question many, many times of our company, our industry, and our colleagues. One of the challenges is because of the fact these things are lasting so long, and our warranty department, other manufacturers' warranty departments will tell you they're even more robust than we thought. They're lasting at least 5 years. Failure rates are less than 0.5%. And because they don't have any hazardous materials like compact fluorescence and other fluorescent technologies, there haven't been any formal recycling programs set up yet. I can give you my personal opinion as to what I think is going to happen based on, again, research and discussing with a lot of colleagues across the industry, is that because of the fact that LED lamps, they're actually cast aluminum, there is some valuable material in the lamp, and that as scrap, they actually have a value. So as with what's happened over the past couple of years, there's now pretty good recycling programs. Actually, if you're in contact with groups like PPG and utilities and companies like ours and other leading manufacturers, there's great recycling programs for compact fluorescent and T8. They will grow for LED, and I expect it will be a very promising thing that there should not be a cost to the recycling programs because of the fact there's a value in the product. So again, the answer right now isn't the greatest. There isn't a lot of programs because they're lasting so well, but I expect they'll come. And certainly if a product of ours fails, we replace it and we dispose of it responsibly.
Great. So up to the next question. We actually have 3 more left. Do you have any viable replacements for PL-style lines?
Another great question, and the question as of the moment is not yet. It's on what we call our roadmap, that there absolutely are replacements coming for what I think you're referring to as pin-based compact fluorescents. There are some out there on the market. I don't think they're E-Star yet. We have some coming, and I expect the other major manufacturers have them coming. So I would say, and actually we almost brought ours to market over the past 6 months, but we wanted to do a little bit more due diligence. I would expect, again, I'm not certain, and we get this question a lot, but I'm quite confident over the next 6 to 12 months, absolutely, I think you'll see that product on the market. But again, be careful, don't proceed with it until you get one that's E-Star. And once again, you wouldn't get incentives anyways. But the answer is, at the moment, no, not many on the market yet, and I don't think any of the brand names do. However, soon, 6 to 12 months, yes, I think they will be coming to the market.
Thank you so much. So how do we choose the right products, taking into consideration the distance the light has to travel?
Okay, it's another great question. That, again, just by working with a good lighting specialist, we take all sorts of measurements. We have tools where we can calculate, and basically we have various types of software. So the first step is we always ask the customer, if you can provide us with a CAD drawing, and what's referred to as an elevated ceiling plan, a reflected ceiling plan, that we can help you with those calculations. We can let you know exactly how many lumens the light has to have to make sure you're getting the right light level at task level and all those good things. So any good lighting professional, any good lighting specialist, they can definitely help you with that calculation and that process.
And then our last question, actually, I think I just saw the person who left who asked this. It's a great question. Any research about studying LEDs in greenhouses?
Yeah, that's another really good question, and that is just starting to come. As a matter of fact, we're working on some really interesting agricultural projects right now. I'm not sure if it's new enough that I haven't seen any formal studies, but certainly we're building case studies as we go. As a matter of fact, right now we're working with several very large poultry farms, chicken farms and things, and certainly the testing that we're doing, greenhouses and other facilities, is that it would make sense, but again, it depends, as I said several times in the presentation, it's all about what is the existing light source. So within the next 5 years, yes, like most every facility, LED will be a great application, but it all depends what you have existing, and you need to get advice based on the existing light source you have in the greenhouse at present.
Great, thank you so much. Thank you to Sheldon and Ed for a great overview. Sheldon, are there any other final remarks that you would like to say?
No, I was just, I believe the person left already, but I wasn't sure whether the disposal of lamp questions was related to LEDs or their current fluorescent or metal halide or HID systems. But she's already left, so.
She has. I think it's a good question if we could quickly address. Yeah.
Yeah, basically.
Yeah, that's a great point, Sheldon. Actually, I was kind of prepared for the question about disposal of LED, so I commented on that, but great point. In regards to disposal of all other types of existing lighting, yes, there are very, very good recycling programs, certainly in the province of Ontario. And again, a good manufacturer, a good electrical distributor, a good lighting professional, as part of their project service, would be able to provide full recycling of all existing lighting, particularly fluorescent, that contains mercury. Critically important that fluorescent lighting is recycled and the mercury does not go into the environment. There's lots of reputable recycling firms that capture 100% of all the mercury, not 1 picogram goes into the environment. As a matter of fact, companies like ours purchase the mercury and recycle it back into the fluorescent lighting. So any good lighting supplier, it's a critical question you should ask. What is their existing lighting recycling support program? They all should have one, and you all should be taking advantage of that. It's a very nominal cost.
Thank you so much. And any closing remarks, Sheldon, before we close?
If anyone has any further questions, they can always contact us. I believe our information is up on the PPG website.
I will be sending out an email to everyone who's attended with all the information and to all the utilities. I encourage you to access the incentives. Again, don't start until you contact the LDCs to receive some money. So thank you again. Thank you to Ed so much. He's come over to our office to provide a great overview on LED lighting. And thank you so much to EnerSource, Sheldon, and Sophie. You've organized this, so thank you again. And thank you to everyone who's joined us. Have a wonderful evening.
Thank you, Alex.
Bye now.